We had a quiz last Friday on graphing linear and quadratic functions, and so this is going to be just a quick review of that. Let's just get right to it. Problem 1, we have to find the equation of the line containing the points 1, 2, and 5, 3, then graph the equation on standard XY coordinate plane. 4 points for correct equation, 3 points for correct graphing of equation. And to be consistent with what we've shown in this class up till now, we've done something called usually 3-column process chart. And so it's just a table with a space in between. You have here X on the left side and Y on the right side. And then you insert your points. The first point we're going to insert is this one, 1, 2. And to do that, we put 1 here on the left side as an X coordinate and 2 over on the right side as a Y coordinate. And then the second coordinate pair, which is 5, 3, we place 5 over on the left as X and 3 on the right. Now, I'm sorry to say that when I was looking at this quiz results last Friday, I saw some, not fortunately many, that put 1, 2 over here on the left side. No, it's the X value is 1, the Y value is 2, then X value is 5, Y value is 3. And the reason we have it this way, we're trying to take advantage of something called the formula to find the slope, which is m equals y2 minus y1 over x2 minus x1. And what this is simply the change in y divided by the change in x. And when we find that, we're going to have our answer of what m is. So to do that, if we subtract, if we take 3 minus 2 on the right side, we're going to get 1. On the left side, if we take 5 minus 1, we get 4. And so right hand over left, we have 1 over 4. And so, and I have some people who like to just decimalize this and make this at 0.25. Sometimes decimals can be easier to work with for a lot of people. And so now we're going to use the formula, the slope-intercept form of an equation of a line, which is y equals mx plus b. And so using this first point here, we have m. Well, m we've decided is 1/4. We didn't decide, we calculated. And x in this case is 1 plus b is equal to this 2 on the right side. And so bringing down the equation, we have 1/4, which is 1 times 1/4, plus b is equal to 2. Now, if we just subtract 1/4 from both sides of this equation, we would solve for b. I'm going to take this 2 and convert this into eighths now. Not into fourths. Now, how many quarters do we have in $2? Well, we have 8 quarters in $2, and so 2 is equal to 8/4. And now if we subtract 1/4 from both sides of this equation, we have 1/4 minus 1/4 cancel on the left side. On the right side, we have b is equal to 8/4 minus 1. I wrote half. I wrote 1/2. I meant to write 1/4 here. Okay, we fix that. There we go. That's 1/4. There we go. So b is equal to 8 minus 1, which is 7. 7/4. And decimalized, that would be 1.75. And so a correct equation for the line is going to be y equals 1/4 x plus 7/4. Or decimalized, it's going to be y equals 0.25x plus 1.75. And then finally, to test, if we go to so we get 3 points for correct graphing of equation. Well, to graph our equation, if we go and we start at our y-intercept of 7/4, or 1.75 would be about right here, and then rise over run of 1/4, we rise 1 and go to the right 4 units, 2, 3, 4, so about right there. And then we have as a line, I'm going to draw a line, try to draw a freehand line here in blue. Not the greatest, but it looks something like that. Finally, we can test our points. We have 1, 2, and this appears to be right on the line here, and 5, 3. 1, 2, 3, 4, 5, and 3. So roughly here. So we have our points. Everything looks good. So we have either this y equals 1/4 x plus 7/4, or y equals 0.25x plus 1.75. To me, they are precisely the same thing. Okay, next. 2. Graph the quadratic function f(x) equals quantity x plus 4 squared plus 1. And I was asked, well, do you have to graph this? Well, the rubric includes, for points, includes 3 points for correctly graphing the function. So if you want to get your full points out of it, that sure you do have to. So what you have is, first of all, what we have is an equation in vertex form, quantity x plus 4 squared plus 1. And the standard form for the vertex form, actually it's called vertex form, is a on the outside times quantity x minus h squared plus k. And the vertex from a function in vertex form is the coordinate pair h, comma, k. And in this case, for this particular vertex, what we have is we have x, if we have x minus h, well then what is h going to have to be? Well, it's going to have to be -4, because the only way we get x plus 4 is if we have x minus -4. So -4 is our x coordinate. And if you just look at this, if you remember your translations, if you have inside parentheses and you have plus a number, that number is going to shift that certain function that many units to the left. If we have x minus, it'll shift to the right. And then we have our k, which is 1. So that is our vertex. Now our axis symmetry, our formula for axis symmetry is this one right here. We have x equals h. And in this case, we have our axis symmetry formula is x equals -4, which is h. And then what we have is so we have a vertex, we have an axis of symmetry, and so that's 2 points, and then 2 points for correct placement and labeling of the axis symmetry. So if we come over here to the vertex at -4, 2, 3, 4, comma 1, so we have that -4, comma 1, and then we have our axis of symmetry right here. So we'll say x equals -4. And the last thing we're going to do is plot our points. And to do that, I'm going to create a table here in the upper right where we have enough room to work this out. And so we have x, and then we have f of x. And our first point, our vertex, we already discovered is -4, comma 1. So we put -4 here on the left side of the table and 1 on the right side. And next, we're going to look at the 3 next highest numbers from -4. So we go up to -3, then to -2, and then to -1. And then going the other direction, going to the minus side, and that would be the left side of our vertex here, we're going to have -5, -7, and excuse me, that would be -6, -5, -6, -7. And then we have our step pattern. We know that A, in this case, A is equal to 1. So our step pattern for this particular parabola is this one here, +1, comma, +3, comma, +5. That comes from our standard parabola. So what we have is we're going to have +1, and the next one's going to be +3, and the last one here is going to be +5. And 1 + 1 is going to be 2. 2 + 3 is going to be 5. And 5 + 5 is going to be 10. And then on the opposite side, we have the same numbers. We have this 2 over here becomes 2 for an input of -5. This 5 here becomes 5 for an input of -6. And finally, this 10 becomes 10 for an input of -7. And so what we have is this, plotting our points. We already have our vertex. We have the point -3, 2. We have the point -5, 2. We have the point -2, 5. There's -2, 2, 3, 4, 5. And we have -6, 5 over here on the left side of the axis symmetry. And then finally we have -1, 10. So we go right up here, -1, 10. And on this left side we have -7, 10. So we have this parabola right here. It's always iffy drawn with this pen, so I'm not looking for artistic perfection in the drawing of this curve. It's mainly getting the dots connected. I try to round at the bottom here because I know that's a general shape there. So very imperfect looking parabola there. But I hope you can see this parabola right here, I'm going to take here, has been shifted over from the parent function parabola here, the y equals x squared, and we move that same parabola with a vertical stretch of 1, factor of 1, 4 units to the left and 1 unit up to be right here. That's all we've done. And we didn't vertically stretch or compress this at all because A is 1. A of greater than 1 would be a vertical stretch, and A of less than 1 would be a vertical compression. Anyway, this is all of it. Good luck. We're going to have we'll have a little test on this later this week. Again, I say good luck, and thanks for viewing.